Now, another aspect of being built to scale, so we have the 8 data centers distributed around the major commerce points in the world. We have the additional 16 CDN points of presence, and all 8 also serve as CDN points of presence, all 8 data centers. Great dimensions, and there's still one other dimension, and I want to point out that these 2 blog posts are similar in concept, where they're trying to talk about the scalability targets of Windows Azure storage generally, and they were updated recently, just a couple months ago, with a new flat network architecture that has extensively enhanced the overall scalability and capacity of the blob and more generally the storage platform. So let's take a peek at that. So Brad Calder is the big brain at Microsoft who runs the storage world there for Azure. And I just want to go, so these are some of the differences between the Gen 1 and the Gen 2. So we're on Gen 2, that's the flat network one. And they've gone to software load balancers instead of hardware because they're more reliable and they could be updated more easily. They use solid state drives for their journaling instead of more traditional moving head hard drives. The network is flat, so it's not hierarchical, which has more hops. And they've increased the storage speed from 1 gigabits per second into up to 10. So that's pretty huge leaps. And as part of this leap, they've upped the capacity from 100 to 200 terabytes, and the transactions, I think this was 5,000 entities per second or blobs per second, and now it's 20,000. So with the new architecture, they've really made some great enhancements. And this is bandwidth for the geo-redundant storage and locally redundant storage. So you can bring into the data center 5 gigabits of geo-redundant. You can exit the data center at about 10 gigabits per second. These are account level scalability targets, and they're the ones for locally redundant, a little higher, a lot higher. So there's some pretty badass scalable stuff. And you get it, like, remember the iceberg, you just start using these things and you get all these features just out of the box, which is pretty impressive, which makes the cost all the more palatable, good costs. So as we go into making copies, number 6 here, we have, I want to get into talking about what the difference is, why it matters with this locally redundant and, where'd it go? The locally redundant, here we go, yeah. The geo-redundant and locally redundant storage, what these differences are. So the locally redundant storage, this is the minimum that you can access with Azure. So I talked earlier about the Azure storage model is not eventually consistent, it's strongly consistent. And that strong consistency is designed to span 3 physical nodes. And by this I mean, if you are this has to do with writing data. If you are writing data using the SDK, or the REST APIs directly, or the PHP API, any of these things, they're all backed by the same REST API, then before the REST API will return to you a success, it will have guaranteed that you have saved 3 copies, it will have saved 3 copies of every byte that you just asked it to write. So if you asked it to write, say, a 4 megabyte block of data, it will have saved that 4 megabytes, each byte in that 4 megabytes in 3 separate places on 3 different machines, on 3 different hard drives. And it's doing this in part in reaction to the opportunity of building a data center on commodity hardware. So this is a pretty big deal. So rather than having high-end hardware that doesn't fail, because we have a bunch of RAID drives or whatever, super redundant RAID, rather than doing that, the more expensive route, the higher-end route, the higher ceremony route, they've gone with this lower ceremony a more cost-efficient mechanism that they call that this local redundancy that basically writes 3 copies, and they expect that they will fail. One of those 3 copies will be lost because the machine it's running on just melted down. It's the hard drive was end of life, or there was a memory chip fried, or something. And somebody spilled coffee on it, maybe. That's less likely than you think, because I don't think they have humans very often trolling around those data centers, but you get the idea. So the idea is that if one of the 3 copies goes bad, they just create a new one. If that drive fails, they just, the operating system that runs storage says, we're down to 2 copies. We better replicate from the 2 good ones right away so that we have a 3rd copy. And data loss is prevented by keeping 3 copies on local commodity hardware. Now, beyond that, there's another level, which is Geo Replication. And this is what distinguishes locally redundant versus geo-redundant storage. The locally redundant is stored 3 times locally. The geo-replicated, geo-redundant storage is actually replicated to the sister data center, and another 3 copies will live there. And this happens transparently to you. It is not strongly consistent like the locally redundant is. When that API call returns, the 3 locally redundant copies are written, but the geo-replicated copies are not written. Those happen asynchronously in the background. I've never heard an SLA or a guarantee on that, but the number I hear is a few minutes, maybe up to 5 minutes for the geo-rep to happen. And this makes sense, right? You don't want to, your application performance would sink pretty bad if it had to wait for a geo-redundant copy to be laid down on a platter 500 miles away. That wouldn't scale very well. So that's why they choose that model. Now, the geo-replication aspect is really a DR model, and it's for Microsoft DR right now. There's been talk of giving you access to the geo-replicated copy for business needs, so you can write it to 1 and read it from 2. But that has not lit up yet. That's speculative. But as a speculator, I would guess that's going to light up in the near foreseeable future, I would guess, so that you could get at those sister copies. Well, another thing that you cannot do is you cannot, as a customer, you cannot force a failover. So this is in place so that if a tsunami hits one of the U.S. East data center, then Microsoft can pull the big switch and fail over the whole data center to U.S. West, the sister data center, and everybody gets DNS gets rerouted and everything just wakes up over in the other data center. This is total loss kind of DR. You have no control over that. That's entirely in Microsoft's control. And as far as I know, that switch has never been thrown for any reason on any of those data centers for customer data. There's rumor that they might add the capability that you can actually manage the failover yourself. So there's some limitations of it, but the fact that you have 6 copies of your data for the price of 1 is pretty cool. Now, there's another mechanism that's available in Azure that is under programmatic control. This is snapshots within a blob. This is pretty interesting. And a lot of people don't know about this. So I'm going to go over to the Cerebrata tool here, and we're going to look at. So I have a couple storage accounts here, and I have a couple of containers within it. I'm sorry. This is a list of storage accounts. There's one storage account. And here are my blob containers. I have one container called Kayak Photos, and it has one blob within it. Now, if I right-click on this blob, I can say Snapshot. Of course, this is all available programmatically, but it's easy to use the Cerebrata tool, which is a great tool. This should be Azure Management Studio. This should be in your toolbox if you're an Azure developer. So I'm going to say View Snapshot. And I can see that I have a snapshot that I took earlier today. And I'm going to, just to show you what I'm doing here, I'm going to take another snapshot. and it makes another copy of it down here. So a snapshot is basically versioning. So so it's the same file, the same blob slot within the container, but it can have multiple snapshots of that blob. So, for example, consider if you were building a source control system for software developers, you may want to use a capability like this, where every time somebody does an update, you basically take a snapshot of the existing one before you allow them to overwrite the most recent copy with the latest code. And you can access these earlier snapshots. So or Word documents, or maybe you keep your monthly reports in the same place. You want the same URL to be able to access them for some reason, and but you don't want to lose the history. And you could actually rig that up with snapshots pretty nicely. So when you ever went to the URL, you always get the latest one. But if somebody ever needed to go backwards, there was a way to do that, and the data was retained.